All right, welcome. We're going to talk a little bit about concentrations of solutions. So as we start, let's define solution. So solution, we're going to concentrate mostly on aqueous solution. So aqueous solution, remember, is when something's dissolved in water. So we have solutes and we have solvents. So solutes, things that are dissolved. And solvents then are things that do the dissolving. So solutions, there's a couple properties of them. So solutions are evenly mixed. The particles they're too small to be seen, and they don't naturally separate. All right, so those are three basic properties. So if we think about salt water, I can take salt, right, which is a solid, and I put it in water, and I mix it up. The salt then becomes the solute, and the water becomes the solvent. If I think about air, right, so air is a mixture of different gases, right? So it can be any phase. An alloy is a mixture of metals. It just has to be evenly mixed. The particles are too small to be seen. When salt dissolves, you can't see the ions, right? And salt water doesn't naturally separate. So they're physical mixtures, they're not chemical mixtures. So a couple things. So we have solutes, solvents. We have saturated. Well, I'm going to talk about that down here. So let me just talk about that down there. All right. So we have. I'll talk about it. So anyway, here we go. So we're going to talk about concentration of solutions. So I can't keep adding salt, right? If I add salt to it, at some point, that salt is going to stop dissolving. At that point, it's called saturated. So we have qualitative and quantitative type measurements. So a qualitative measurement is something where I just state something without measuring it. So we have two qualitative measurements. We have dilute, and we have concentrated. So this word saturation is when a solvent is holding max solute. That's what saturation means. So dilute means having little dissolved solute compared to carrying capacity. So this right here, you could say is at carrying capacity, right? So dilute is far from saturated, and concentrated is close to saturated, right? So those are just ways that we look at it. If I want to make a concentrated solution more dilute, I add more solvent. If I want to make it less dilute, I remove solvent, right? Or more concentrated, right? So dilute, concentrated are probably terms that you've used before. But we're going to give you a couple mathematical or a couple qualitative or quantitative, sorry, quantitative means to measure. So the first one we're going to talk about is molarity, right? So molarity is moles solute per liter solvent. So it's moles over liters. So if you have grams of solute, you have to go to moles first, right? And you have milliliters, you have to go to liters. So that has to be in these units, right? So so it has to be in those units. Okay, so molarity and molality. So I'll give you an example here. So I have 73 grams of HCl powder is dissolved in 4 liters of water. So I can't go 73 grams in here. The HCl is the solute, the 4 liters of water is the solvent. But the problem is that the grams is not in moles. So I have to take this and convert to moles first. So 73 grams HCl. And I've got 36.5 grams per mole. I get 2 moles of HCl. So, or and the symbol for molarity is a capital M, right? So that symbol for molarity is a capital M. So I get a 0.5 molar solution. So if you read in the last lab that you did, you use 6 molar hydrochloric acid, 6 with a capital M. That means there were 6 moles per liter. A concentrated solution of hydrochloric acid would be about 12 moles, because that's near saturation. So it's about halfway saturated. All right. So as you do your homework, molarity is pretty easy. It's just moles over liters. So just remember, when you do your saturation, it's moles solute over liter solvent. Molality is a little bit different. So it sounds similar, but it's not. So it's moles solute per kilogram solvent, right? So molarity and molality for aqueous solutions is the same, because water is 1 milliliter. So water equals 1 milliliter equals 1 gram. So 1,000 milliliters is equal to 1 kilogram, right? Or 1 liter is equal to 1. So liters and kilograms for water is about the same, but it's not always water, right? So just important to know that. So I've got 117, in this example here, I've got 117 grams of sodium chloride. It's dissolved in 1,000 grams of water, right? So I've got to start out, and I've got to convert that to moles, because it's still moles over kilogram, right? So I've got 58.5 grams, and I get 2 moles, right? Sodium chloride. And then if I think about my 100 kilograms here, my 100 grams, that's 1 kilogram. So again, I get 0.5 moles. So now, it's a lowercase m. So make sure you make your molality lowercase m and your molarity an uppercase m. So you're going to have to lowercase. But remember, here it is right here. It's mole solute over kilogram solvent. So they're similar, but just a little different. Okay, and I'll give you easy examples most of the time because this is summer school. All right, percent solutions. Last one. Right, so a percent solution, a percent is just a part over the whole. That's an easy way to think about percent. So it can either be V over V, right? Or volume over volume. It can be M over V, which would be mass per volume, or it could be M per M, which is mass over mass. Okay, so it's important to remember, right? So I'll always tell you, right? So if I have, I want to make a 25% M over V solution. Using 500 milliliters H2O, right? So the way you would do a problem like this is I would say that X over 500 grams, because remember, water is 1 gram is 1 milliliter, is equal to 0.25, right? Because this would be my percent solution, mass by volume, right? So all I would do is then move my 500 over here, and then solve, right? So I just simply move that. Okay, so not too hard. So today's pretty easy. I'll post some more stuff if you guys need more help. Otherwise, good luck for this week, and I'll talk to you soon.